Hello, I'm JW. This time another piece of equipment to have a look at. And this has been sent in, although it was shipped directly from the Chinese manufacturer. So here it is. It's one of these touch sensitive light switch type things, so still in the wrapping there. And it also comes with one of these, which is a radio remote control with the 4 buttons on it, which looks suspiciously like one of those generic jobs you can buy to clone existing remotes. So I'll have a look inside this one and also of course power it up and see how well it works and take it apart and look inside. So here's what we get, basically just a plain white box, Y601 in the label there. This is obviously a generic product which is probably sold under a variety of names, so it's plain white. Here's the actual thing itself, so it's just a touch sensor in the centre here. The front of this is apparently actual glass, although we'll see whether that's true or not later. And on the back here, just the terminals there, so it's basically line in, and then you would have line out here. This is only a single button model obviously, but if you had the others then you could have 3 separate outputs. And it's just a single pole switch, so it's basically power in and power out. Claims to work from 110 to 240, and anything from 3 to 300 watts per gang, although only got one in this case. And only up to 150 watts if you're using LEDs, energy saving and all that, which is pretty much what you're going to be using these days. Mounting screws also has a capacitor, which is mentioned in the instructions, and we've got this little remote control which looks exactly the same as the ones you can buy as sort of clones, where you can say buy one of these to operate your gates or garage door or whatever, and you can just basically program this from an existing control, so into whichever button, and then you just press the button to obviously open your garage door or whatever. And I say this looks to be exactly the same as those ones you can buy, which does make you wonder whether it was even designed for this product. Instructions here, which are actually all in English, and on the back here we've got them showing how it will be installed. So quite surprising that there's no other languages there. I suppose depending where you buy it, it might have that included. So installing then, just pry the front off. That's obviously one with the 3 sensors. I've only got one on this one. Wiring here. Fire wire comes in. I'm sure that's not the proper use for that term, but basically it's line in here. And then you've got 3 line outputs if you've got the 3-gang version, which obviously goes to the light, and then the neutral connects elsewhere. Now a problem with this is that it's obviously receiving its power by allowing a tiny current to flow through here at all times. And the problem with that is that with certain types of lamp, LEDs in particular, a tiny current flowing through can cause a thing to flash or glow extremely dimly, which is also why they've provided this capacitor. Fixing to the wall and so on. You can pair the remote control to it. Oh, I see, so it's just basically the thing itself will this doesn't have its own set code. You just basically use any old remote you happen to have, and then this can learn the code for it. So you can have this program to open your garage door and then turn your lights on at the same time. Not very practical. And on the back here, tempered glass on the front apparently. Fire restriction polycarbonate on the back. 3 to 300 as we saw before. Yeah, the frequency is 433 megahertz, which is exactly what these are, and it's a good thing it's that, because that's one of the very few you're actually allowed to use in the UK, so that's probably just a generic control. And then it's got the installation of the capacitor, so basically this is the light fitting, and it says just to stuff this between line and neutral on the back, and that's to avoid the light flashing, as it says here, because otherwise, say that way, the current will actually flow through this rather than the thing in the lamp. Depends on the kind of lamp that you've got. Let's have a look at the main event here. So it basically says just shove a screwdriver under here and pry the front off. Right, so there's the front. It is just literally a piece of what claims to be glass, plastic back frame, and then also you've got your sensor in the middle here, so just a capacitive type arrangement. Let's check whether this is actually glass. It feels yeah, I think it could be glass. It's say a bit job to tell because it's been inside, so it's quite warm, but yeah, I think it is glass, so there we have it. Screws on the back here, so just attach it to your normal wall box. That should be the standard UK mounting, although I see it's got these horrible slotty bits here, which are the ones that tend to slip around once it's on the wall. That will be just the capacitive sensor on the front. Appears to have what could be LEDs on the front there, presumably to light up through the front panel. And then on the back it is literally just the two terminals, so line in and line out. So can we get in here and see what's on the back? It doesn't appear to have any visible fastenings, so okay, I think they've actually just glued it in with tape. I can hear the tape peeling there. So if we just pry underneath, we should be able to remove it. Okay, so we take out the screws then, it should just drop out. So there we have it. So they've just literally put a bit of tape there to stick that onto the back. I've got a 6-pin connector here which just goes into that thing down in the bottom. So this will be the actual sensor part. I seem to have another smaller board stuck on the top of that as well. So it's a rather unusual design. And we have got some screws down in there, so we'll certainly be taking those out. So just remove these little screws in here. So just black plastic case, claim it's polycarbonate, which might be true. It's not marked anywhere else, but there we have it. So what we've got here then is the main thing. It seems to have what appears to be a buzzer on it for whatever reason, and this will be the basically the power in and the power out here. Interesting how they got this huge area of copper all covered with the one of the terminals there. So nothing on the back there other than that 6-pin connector goes through to the other board, and on this side then just the two terminals for the power coming in, and presumably a little switch mode power supply to provide power to the other part over here. That device there is presumably what does the actual switching on the output. So a little buzzer there, presumably it's a beep when it's been programmed or whatever else. And the rest of that is probably mostly just going to be for the power supply down on this corner here. Yeah, there's no known brand on that capacitor. So that's basically going to be your power supply and the switching for the output. And the way that these things can work with only a line and a line out is that when it's in the off position, the small leakage current can actually go through the lamp. And typically we say a filament lamp or incandescent. Although the thing's not lit, there is of course a continuity between it, so current will flow through here, charge up the capacitors and whatever inside, and then of course go back and go through the lamp. Now that obviously works fine when you have a filament lamp, but if you have an LED or whatever, then say it can result in that small current charging up the capacitor in the LED lamp until it gets to a certain point where the lamp will turn on, and then because there's no actual current flowing really, the lamp will go off, and then it will continue going on and off and flashing, or in some cases it just remains on at a really dim level, which is rather annoying. But that's how this gets power. It's just basically using a tiny leakage current through the lamp itself, and to turn on all it does is connects these two terminals together, so then the full current will flow and illuminate the lamp. That does mean this is not powered during that period, but then of course you've got your capacitors in here which should be enough to power this whilst the terminals are actually shorted together. And then of course when the lamp turns off or this thing disconnects the two, then a little tiny current flows again to recharge the capacitors in there. And the top board here we've got basically the piece on here which will be the capacitive sensor. That just presses on the back of the glass there, so you can when your finger is there it just changes the capacitance of this, so you can also detect that. And as well as those two there, we've also got this piece here, which is obviously a second board that's been basically glued down and then just soldered across here under that tape. And given the fact it's got those pieces there, they look like some kind of antenna, so that's presumably what receives the radio signals to control this thing remotely. Nothing on the other side. I'd say those appear to be two LEDs there to illuminate the front plate. Well, I had a quick look for the actual numbers on the chips there, but despite them having numbers on, none of them seem to make a great deal of sense in terms of what they're actually for. But in any case, two on there. This is just going to be the power supply, so nothing too surprising there. But let's put this thing back together and we shall see if it actually works. And then of course if it doesn't work, is that because I've broken it, or was it broken when we actually got it? But nevertheless we'll stick it back together to see what happens. Now I'll set this up on the other workbench so you can see if this does actually work. So fairly straightforward. We've got the switch here and we've got the two wires there, which is basically line in and line out. Line out just goes to this filament lamp we have here, and the neutral of that just goes back to the power supply. And the line, rather than going straight to the switch as it would normally do, I put it through this meter here so we can see how much current this thing uses. So it's basically line in here, through the meter, into the device, out of the device to the lamp, and then back to the neutral to complete the circuit. And so this does not have any neutral connection, it is just purely the two line connections there. And the way that these work, as I said in the other segment there, is that when power's applied, because this is a filament lamp and you've basically got a complete circuit, a tiny current will flow, nowhere near enough to make this light up, and that will charge up the capacitors in this device, so it has a little power supply. And then of course to turn it on, it's basically just connecting those two pins together, so then the full current flows through the lamp. Now I've actually got a switch on this lamp holder here, so we can actually turn this on and off separately. And the meter here at the moment is on a 2 milliamp scale, so decimal point here, so this is basically microamps reading just here. As the current this uses, of course, is very small, which is of course exactly what you'd want it to be. Now I've got the lamp in the off position currently, so there's no circuit there, so if we just turn on the actual power. Now this meter is actually showing 2 there, which is some effect due to the wires in proximity, but at the moment there's no current actually flowing through the device. Now when I turn this on, what we should see is that the current will rise and then gradually fall away as the capacitors in the switch charge up. So let's just see that. So you see it went up sort of in the 50 microamps range, and now we're sort of holding in the sort of 37, 38 kind of area, and that's in its default off state. Now when it's in this state, this thing here in the square in the middle here does actually light up blue, but it is ridiculously dim, so we'll look at that with the lights off later, but it would be enough to see in a completely dark room, and obviously that's mainly why it's drawing the current continuously. So we can turn it on by pressing this, and also we can attach this remote control to this. But before we do that, we'll just change the meter to a more sensible range, because obviously 2 milliamps is not going to be any good for this particular lamp. So on the 200 milliamps scale now, so that's basically milliamps on there, and switching on, it's just press it and it lights up, and this is drawing about 150 milliamps. This is a 40 watt lamp here, and then it's just press again to switch off, and again the current will basically drop down to 0 as the actual amount it's drawing is literally in the microamps range. And that's what you want, because you don't want this thing to be using any kind of significant current, because if it did, even though it's turned off, it's still using power. That could end up being fairly costly, but as you see there, it's pretty much 0 on this scale, as we saw it's in the tens of microamps range. Now this remote control, which does seem a rather strange addition, can be attached to the thing here, and basically just hold it, and then it beeps, and then you press the button you want, and then now that button is now programmed to turn the thing on and off. So it works pretty much as described, but so it seems a bit weird to have one of these turning the lights on and off in your house, but nevertheless it does the job as described. And of course you can program the other buttons for other devices similar to that. And it seems that you can also program this, as well as what we did there is actually on and off. You can try to do it so it just button will just turn it on, and another button will just turn it off, which seems even less convenient. and then you can obviously erase the thing from it completely, and that's just basically by holding it, and then it will beep once, twice, 3 times or 4 times. And then depending on how many beats it is, and then when you press the button as to what function it actually does. So 4 has actually deleted it there, as you see. So 1, press the button, and now that will turn on and off as before. Now, so this is actually a filament lamp here, so that's actually a 40 watt variety. So notice it's actually 250 volts, so perfectly suitable for use here with our rather high voltage. Most of them are 240 for the UK, and nasty ones from Europe are 230 because their voltage is somewhat lower. Now I've got here an LED one. This is a 4 watt LED. It's one of these filament styles, so it's basically 1 watt per sort of filamenty thing inside. They're of course not really filaments at all, and this may cause problems, which is why they supplied the little capacitor thing here, which you can basically put across the terminals of the lamp. You could put it on the bottom of the holder there if you needed to. But let's just see what it does anyway. And if we just turn on here, we won't see any current there because we're on that 200 milliamp range. Okay, well it does seem to turn on as expected. Current there's about 13 milliamps there. Power factor this would probably be horrible, so current on its own doesn't really tell us a lot, but nevertheless it does seem to work perfectly well, so no capacitor needed there. One problem that you can get on these is that because of the tiny current that flows, it will charge up any capacitor in the bottom of this, and then it will just get to a certain voltage, and then it will just cause this to flicker, but of course then the thing will go off again, and then the current will charge the capacitor, and it will flash once and basically repeat forever. But in this case, it doesn't seem to be doing that. There may not actually be a capacitor in there at all. I haven't taken those particular ones apart. Another thing about here's one of these compact fluorescent things. This is a 11 watt version. So let's see what goes with this one. So see if it does actually turn on. Yes, it does. So that seems fine. These again may have the same effect there, where the tube will sort of flash once and then there'll be a delay and it flashes once, but in this case it doesn't seem to be doing that at all. Now just turn off the light there, and you can just about see here at the bottom, that's the actual illumination on the switch there. Just putting my finger across the top of it. So it is visible, but it is incredibly dim. That orange thing over there is the neon in the power supply thing. So as you can see, that's just a standard neon, hugely brighter than this, literally just this tiny little blue square. But say you're in a completely dark room, then you would be able to at least see that. But that's certainly incredibly dim, and it actually looks a bit brighter on the camera here than it does in real life. So even dimmer than it appears at the bottom there. So that's it is illuminated, but ridiculously dark. So it seems to work with fluorescent and LEDs without any need to install the capacitor. Although, say, they did provide a thing if it was required. It's just the screws to fix it to the wall. And say it turned on and off again with the remote and everything, as you would expect. So in terms of device, I mean, it seems reasonably well made, and so this is a single pole. You can apparently get them with 2 or 3 things on the front there. The only disadvantage there is that they're all common together with a single input, so it's the single line input and then 1, 2 or 3 outputs, so wouldn't be any use if you've got 2 circuits in the same back box. And the other thing with these is you can't use these where you have 2 or more switches operating the same light, because this is just a single pole switch here. So basically it's not going to be any good, say, in a stairway or something where you might want to turn it on and off from upstairs and downstairs. But nevertheless, I mean, it seems to be reasonably well made. I mean, the back is all pretty much enclosed there. It's got decent terminals, and the screw holes here are the standard spacing for UK boxes as well. And the front is glass, so it was a bit difficult to tell inside because it was quite warm, but it is glass and seems reasonably good quality. So that's it for this time, and until next time, thanks for watching.